All right, AP Environmental, good morning. Today we're going to continue with Unit 8, topics 8.2 to 8.8. Again, we've been talking about all these different types of water pollution, human impacts on water, involves all these things. So today we're going to focus on numbers 5 and 6, oil spills and persistent organic pollutants, otherwise known as POPs. And again, just as a reminder, one of the big learning goals for this is to make sure we understand the causes, the sources where they come from, especially anthropogenic sources, and then also the effects on the environment. So let's first talk about oil pollution today, and just to kind of revisit this a little bit, I want to talk a little bit about some of the major um, oil spills or major environmental incidents that have occurred due to oil getting in the water. The Exxon Valdez, we've talked about this before, happened back in 1989. It was an oil tanker that basically ran into some rocks up in a place called Valdez, Alaska. It was a single hull oil tanker. What that basically means is that there's just one hull to the boat. It's just like one casing around the oil. So if anything happens to that hull, if it cracks or it breaks open, then of course all the oil is going to spill out of the tanker. And in this case, it was 11 million gallons of oil. And you can kind of see what the repercussions of that were here on the environment. It's estimated it'll take over 100 years for all of that oil to break down and for the environment to eventually be back to normal. One of the big results from this, which I think is kind of an important thing, is that after the Exxon Valdez incident occurred, they did pass laws that now require oil tankers to be double hulled. So there's kind of two barriers around the oil in these oil tankers, just in case something happens. So we haven't really seen um, an oil spill to this magnitude since the Exxon Valdez. So that's kind of an important thing. There have been some oil spills, but nothing to this magnitude. And maybe part of that is due to these laws that have been passed. So probably a good thing. Offshore drilling. This picture here is showing us an offshore drilling platform. These things are almost like floating hotels. They're gigantic. You can see the picture here, but they're drilling for oil, on these platforms. There's over 5,000 of these just in North America alone, and many more around the world. A lot of these drilling platforms do experience leaks where oil can get into the water. It's estimated over 300,000 pounds of petroleum leaks into North American waters every year, all because of the platforms. Um, in the United States, we do have a lot of laws in place that, kind of keep a lot of these oil platforms in check as far as monitoring them and seeing if there's any leaks and things like that. But other places around the world, those restrictions are not in place. We talked about the Deepwater Horizon that happened in the Gulf of Mexico in 2010. There was an explosion. It caused a pipe to break on the ocean floor. And in this case, over 200 million gallons of oil leaked into the ocean, which was 20 times larger of an environmental incident compared to the Exxon Valdez. So you can understand the magnitude of this one. But again, all of this oil, it has to go somewhere. So a lot of it is still there, either floating in the ocean, sank to the bottom of the ocean, it washed up on shore, and can have a major environmental impact. Now, today I want to talk a little bit about how we get rid of this. How do we actually clean up an oil spill? It's like one of the dirtiest things on the planet is an oil spill. So, when the oil does spill out of a boat or wherever it's coming from, several things can happen to it. It can sink to the bottom. It can float on the surface. It can stick to animals. It can adhere to animals, or it can eventually just wash up on shore. So there's generally not just one technique that we use to clean up oil. there's usually multiple things that we end up having to do because we have to get all this oil, um, you know, cleaned up from different things. For surface oil, two of the things that we generally use, they have like sort of like a vacuum pump that they can kind of suck the oil off the surface, and that's somewhat effective. If you have an entire oil tanker that spills, it might be a little bit more difficult, but maybe for smaller oil spills, that would be effective. This picture on the upper right, these are called sorbent cloths. They're almost like paper towels, but they're made of special materials. And again, they just kind of lay those on the surface and they absorb the oil. Again, but these are only good for surface oils. They're not good for the oil that's under the ground and things like that. Occasionally, they'll use chemical dispersants where they will basically just spray chemicals on the surface of the water. And these chemicals are usually pretty effective at breaking the oil down and not allowing it to reach the shore. I'm going to show you kind of a little bit of how this works. This picture here is kind of showing you, this is the bottom left. These are the molecules. These are the chemicals that they use to spray. So these are the dispersants, they call them. And what those dispersants do is that they have two ends to it. And one end of it sticks to the oil. It'll stick to an oil molecule. And then the other end of it will stick to a water molecule. So if you look at this picture here, number one, you've got an oil droplet, and you've got all these dispersant molecules that have kind of adhered to it. Well, on the other end of those dispersant molecules are the water molecules. So, the water's, it moves like this, it moves in a wave-like pattern, and, it's choppy, and it ends up breaking apart those oil droplets. So it essentially breaks them into much smaller pieces, and those smaller particles can sink to the ocean floor. Some of them can stay suspended, but most of them will actually sink. So it is a good way to at least um, break that oil down so it sinks to the bottom and doesn't stay on the top, and that way it won't get to the shore. So, I mean, is it a perfect solution? No, but at least it'll kind of stop the oil from getting somewhere that we don't want it to get to. One of the problems with those dispersants is some of the chemicals that they use can be toxic to marine life. And again, because you're breaking the oil up and it's sinking to the bottom, the organisms that live on the bottom of the ocean might get more of an impact of that oil than, of course, the organisms at the top. So, I mean, it's not a perfect solution, but it is something that they use to break up the surface oil. This is something that I personally I think they should look more into, and I think maybe the future of cleaning up oil spills might lie in this example here. This is called bioremediation, right? To mediate in this case, or to remediate in this case, is again to break the oil down, and in this case, maybe even get rid of it. But here we actually use organisms. We use things like bacteria, funguses, algae that actually will consume the oil. They'll actually eat it, and they'll break it down, and their byproducts are basically they go up into the atmosphere instead of just lingering in the water. So this would be a good way to actually get rid of the oil completely. And they do use these things. The problem is they're not really that effective for like big oil spills. They're effective for like smaller, spills, smaller volumes of water, and they can kind of help a little bit take care of some of the oil that's reached the shore. But there's some drawbacks to these because again, it's not really that useful for large oil spills. But bioremediation is something to really, I think we should look more into that down the road. All right, now the other type of water pollution I want to talk about today is POPs, persistent organic pollutants. Now, persistent organic pollutants, before I get started here, there are a lot of them, all right, different chemicals. But I'm going to go through a couple of the more, I guess, common examples of them today. But before we get into some of the specifics, the specific examples, I want to talk a little bit about what persistent organic pollutants are. First of all, they're synthetic. all right, which means that they're made in a lab. These are human-made compounds. They're usually used in industry, and a lot of times they just get put into the environment because those factories are a point source, but occasionally they can be non-point sources as well. But they are man-made compounds, they're not natural compounds. They are also persistent. The word persistent means that it stays in the environment for long periods of time, so they don't break down very well. They're organic, and if it's organic, it means it contains carbon. And if you know much about organic chemistry, which I'm guessing you guys don't really, but organic compounds typically contain these 5 carbon rings. So this picture here, for example, this is a picture of DDT. We've talked about DDT before. It's a persistent organic compound, and you see this kind of ring structure here. All right, that's a 5 carbon ring of carbon, and typically, actually, this is a 6 carbon ring, but that's okay. It's these rings of carbon, and typically when you see these carbon rings, you usually see them bonded to chlorine if it's a persistent organic pollutant, but not always, but most of the time that's the case. So if you ever see, a picture like this that has these ring structures to it, and you see chlorines bonded to it, most likely it's a POP. It's a persistent organic pollutant. They're non-polar. Again, if you don't understand the chemistry of what that means, the big thing about nonpolar substances is that they tend to accumulate in the fatty tissues of organisms like fish. So bioaccumulation, we talked about this the other day. It can build up in the organisms, which means it can also eventually um, biomagnify, which means it can make its way through a food chain. So these persistent organic pollutants, they can linger in the environment and they find themselves in food chains, and that can be problematic. Another big thing about POPs is that they can easily be carried long distances. I mean, we're talking like from one continent to the other. All right, there are persistent organic pollutants that make their ways from Africa all the way over to North America. So, I mean, that can be kind of an issue. Literally, they can cross the Atlantic Ocean. So they can be carried pretty easily through long distances through wind or water. All right, the Stockholm Convention. Stockholm Convention it's a treaty. It's an international agreement that was signed in 2001 by 152 countries, and the whole aim of it, the whole goal of it, was to eliminate the use of persistent organic pollutants around the world. Originally, the Stockholm Convention listed 12 compounds. I mean, you can Google it if you want to find the names of the 12. But they called them the dirty dozen. So there were like 12 chemicals that 152 countries agreed to, like saying, hey, we're not going to put these things into the environment anymore. But not every country signed this. Not every country agreed to it. So there are still some countries around the world that do, or where you see some of these pollutants get into the atmosphere, get into the water. But since 2001, there have been more than just 12 compounds listed. There's actually, I want to say, 25 or something now that's actually been listed. But originally there was 12. Now, a few examples of these are the ones I want to just kind of go over today with you. Endosulfan, DDT, which we have talked about, PCBs, you don't know what those are yet, and then finally something called PBDES. So let's just kind of go through these individually, and I'll kind of explain what they are and kind of why they're not good to have in the environment. Endosulfan. Endosulfan is a pesticide. In fact, a lot of the dirty dozen, a lot of those chemicals are pesticides. So this is one of them. It's a broad spectrum, right? Which means it kills a lot of different things, which is probably why it was used so much. It was used to kill insects. It's a pesticide, but it also can kill amphibians. It can even cause human birth defects. So this is a banned substance in 152 countries. We don't want this getting into water supplies, and getting into people's bodies and things like that. Not a good thing. DDT. DDT is another one we talked about before, so just want to briefly go over this one. Again, this is another broad spectrum pesticide. Again, it makes its way into the environment. It doesn't break down, right? Um, Again, it affects the nervous system of insects because it is broad spectrum. But again, also it can bioaccumulate, it can biomagnify. If it gets into birds, in high concentrations, it affects their eggshells. Again, this I showed you a video, I think, a while back about like it showed you the difference between like a normal bird egg and a bird egg that's been tainted with DDT. And the eggs end up looking like this. So the American bald eagle almost went extinct because of DDT. So that was kind of a big issue. A lot of these chemicals, a lot of these POPs compounds, especially pesticides, um, a lot of them don't have to list all of their ingredients, all of their inert ingredients, we call those things. And they're protected by law. We talked about this when we were discussing fracking fluids. Some of those chemicals in those fracking fluids, they don't have to list them because they're trade secrets. It's like the Big Mac special sauce. McDonald's doesn't want their special sauce to be known to the public because that could ruin their business. So same thing. So a lot of these businesses that produce these chemicals, they're not required by law to list them, and they also don't have to test them for safety. Now, those laws are getting a little bit tighter, which is a good thing. But right now, some of these companies get away with this because they don't have to tell us exactly what they're putting into the environment, which is problematic. PCBs. PCBs are what we call polychlorinated biphenyls. So you don't have to like spell that word or anything, but you should recognize it. Okay, polychlorinated biphenyls, PCBs. This is another persistent organic compound. PCBs were used heavily back in the 1970s, the 1960s, the 1950s. They were used to manufacture plastics. They were also used to manufacture electrical transformers, like you see here, used to help transmit electricity. They are no longer used in the United States. Again, they are one of the dirty dozen. But a lot of these PCBs are still in the environment, even though they haven't been used since the late 1970s. Quick story about PCBs. General Electric, which is one of the world's leading appliance manufacturers. Back in the 1970s, actually for about 30 years prior to the 1970s, General Electric was found guilty of putting over 1 million pounds of PCBs into the Hudson River, which is in New York. In 2002, the EPA said that you gotta clean this. I mean, the Hudson River is so contaminated with PCBs that you can't even put your toe in it. I mean, it's so polluted. So they said that GE's got to pay for the dredging of the river and remove all these chemicals that they put in it. So GE said, well, wait a minute. If we do that, if we go in there and try to stir up all those chemicals because they all sink to the bottom, then it's going to cause even more problems than what it's worth. So this went back and forth in the courts for about 30 years. And then finally in 2009, the courts finally said, no, that's it. You will clean this and you will clean it now. But again, it was over 30 years of court litigation to eventually get GE to clean up the Hudson River from all these PCBs. So in the meantime, for 31 years, it was an absolute mess in that river. Finally, today, this is PBDEs. PBDEs are polybrominated diphenyl ethers. What you should probably know about them is that they are used as flame retardants. They're used to maybe basically make things less flammable. They're used, or they were used quite a bit in construction materials, furniture, even clothing. Like for example, mattresses. For example, they were used to make the mattresses flame retardant so they wouldn't catch on fire. But they've been found in the tissues of birds, fish, even human breast milk. If they get into the environment, they're linked to brain damage in children, just like a lot of these other POPs compounds are. So here's just a picture of some different things in your home that or where that usually have flame retardants in them. But again, PBDEs are now banned, but they haven't always been banned. So I mean, some of these things are still in the environment. For example, like an old sofa, that's no longer used and makes its way into a landfill. Those PBDEs get into the landfill. Okay, so that's an issue. All right, guys, that's it for today. Enjoy your weekends, and I'll see you guys next week. Take care.